Fundamental counting principle. However, it uses it in a slightly different manner. So here, this first example we've got how many different batting orders can be created with 9 players. So if I think about that, I know a batting order is 9 people. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 different decisions to make. Now here's where it gets a little bit different. So if I've got 9 players, and I know I'm going to be multiplying all of these together, when I choose that first player, I've got 9 players to choose from. Now, once I put someone into that position, here's my baseball player, I now have lost one person off that list of 9 people. So my list here, I now have crossed someone off my list. Now for this next spot in the batting order, I now have 8 people left to choose from. Because one person's already been placed. I can't choose them again. Order does matter, and I can't have someone back twice. So now, if I pick that second person. Now in the next spot, this is going to be a 7 because these 2 players have already been chosen. I can't choose them again. So now I have my 7 people. And I bet you can start seeing a pattern here. So then, once I've chosen that person, I'm now left with 6 to choose from, then 5, then 4, then 3, then 2, then 1. And I'm going to take and multiply all these together. I am perfectly okay with you using a calculator for this because I realize that these can be some larger numbers. And in fact, to save time here, I myself am going to use a calculator that I have handy with me. And when I go ahead and do that, I am going to take 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that gives me an answer of 362,880 lineups for batting order. Now, I don't know about you, I don't want to make a list that big, and I don't want to make a tree diagram that big. Now, here's something that's really cool because typing into a calculator or doing by hand, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, can get very long. This is where something that is called factorial comes in. And we've talked a little bit about factorial when we've done bowling. What factorial is, that's going to be used with the exclamation point symbol that you've probably seen on the calculator we've talked a little bit about. And all it simply means is that you're going to multiply all integers from their starting number, in our case 9, down to 1. As you can see, we have done. So in this case, this would be known as 9 factorial. And it'll help you out. Now, it won't work in every situation, but it will work in some. Let's move on to this next example. A standard license plate is created with 3 numbers followed by 3 letters. In a particular state, the first number cannot be a 0 or a 1. How many different license plates can be created? So when I think about this, my license plate is going to be 3 numbers followed by 3 letters. So when I look here, it says the first number cannot be a 0 or a 1. Well, if I think about all the digits that I can possibly use to give myself an opportunity to create this, I can't use a 0 or 1. There are 10 possible digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But I can't use a 0 or 1 in the first spot, so that means I have 8 choices here. Now it doesn't say anything about numbers not being able to be repeated, which means in my next spot, I'm back to a 10, because there are 10 choices that I can have, because I'm no longer limited to the not having a 0 or a 1. The next spot, Even though I use numbers already, I can still use them again, so this is still 10 choices. Now, I'm going to change this for the sake of not screwing up and thinking subtraction. Now, when it comes to the next three, it's 3 letters. Well, I know that I can repeat letters if I would like, and I have 26 letters in the alphabet to choose from. And then I still have 26 letters in the alphabet to choose from, and then I still have 26 letters in the alphabet to choose from, because this could possibly be 555 AAA. It does not matter. So then I'm going to go ahead and take my trusty calculator, and this one can't use the factorial, but I can type in 8 times 10 times 10 times 26 times 26 times 26. You could do 26 cubed if you would like. And that gives me a solution of 14,060,800 license plates. And that is why they have the combinations and the codes that they do, because they need to allow for a lot of people to have a lot of license plates, especially since some people have multiple ones because of multiple vehicles. All right, let's take a look at our last example for today. This one's slightly different. Now, we have 15 books on Alan's Kindle that he wants to read. We want to know in how many orders can Alan read 6 of the books over the summer. So he does have 15 books, but he wants to read 6. So that means I've got 6 decisions to make, because he wants to read 6 of those books, and he wants to know how many different ways he can pick out 6 books. So this is like saying, this is book 1, this is book 2, this is book 3, this is book 4, this is book 5, and this is book 6. And I don't know about you, but if I was given 15 different titles and told how many different ways can I read 6 of them over the summer, I don't want to figure that out by reorganizing them and making a list. So when I look at this, I have here that when I first pick when Alan picks his first book, he's got 15 books to choose from. Now, once he reads it, he's got 15 books, so he's not going to read books multiple times. So once he reads that book, as you can probably guess, he will have 14 more books to choose from for book 2. And then I'm going to have you pause it, finish filling this out, and see if you're correct. All right, let's see if you're correct. We're going to have 13 books for the next choice, and then he'll have 12 books left to choose from for book 4, 11 for book 5, and 10 for book 6. So this is kind of like using factorial, except as you notice, we're not using the 9 factorial on down, basically, which you could factor that in, but that's a lot of extra math, so let's only do what we need to do. So if I take 15 times 14 times 13 times 12 times 11 times 10, which is exactly what I have here that I need to do, I get 3,603,600 different orders that he can put these books into to read over the summer. So he's got a lot of choices to make. Now, what your job is going to be is to complete these 3 problems. I'll scroll back up and give you an opportunity. Books for problems, you try problems for class for Monday, and then bring any questions with you to class.